Alright, then I will start sharing the slide. I'm sharing the screen. Sharing. Can you guys see the slide?
Yes.
Okay, so first, all right. Thank you for the feedback. Let me paste first the attendance link. All right, so that's the attendance link. Please mark your attendance once we finish the class, yeah. Okay, so let me put the slideshow. Okay, right. All right, this will be my third weeks, yeah, with all of you. And so here is the link, all right. And today's topic is EDA, exploratory data analysis. Okay, but before we start the class, let's us recap back last week class, yeah, week number 10. Okay, on the experimental design. Okay, so last week, if you remember, we have like introduced to you. I have introduced to you about DOE. What is DOE? Yeah, it's a design of an experiment, which is a conceptual structure. Yeah, to for us, yeah, as a researcher to conduct, or in other words, it's like a blueprint for the collection, measurement, and the analysis of data in your research study. Okay, so do also remember what are the features of good design in experimental design. First, we need to minimize the bias and maximize the reliability of data that you have collected and also analyzed. Second, we need to achieve a smallest experimental error as possible, to achieve a smallest experimental error, okay, but yields a maximal information, and to consider various aspects of a problem that we want to solve. Okay, and I do hope also that you can differentiate between IV and DV, which is independent variable and also dependent variable, and have a brief understanding on all of the experiment concept that I have introduced to you in the last week class, especially on the extraneous nuisance variable control and also the random variable, random behavior. Right? So do remember also the three principles of when we want to develop an experimental design. There are, the first one is the randomization, replication, and the last one is the local control. Okay. Okay, so for this week, we're going to cover on the EDA, exploratory data analysis, which has two subtopics. They are sampling and how you're going to display and also summarizing your data. right? Okay. So graphically, we will present the EDA concept in these infographics. All right. So basically, when you have the access to the data, you can already start the data exploration, right? This is the base for creating a meaningful summaries of your data, and it's particularly very important if you are unfamiliar with the data, right? So you need to understand the data first. How to do that? How to understand your data? You need to explore your data. Okay, this is also the time you should test your assumptions. Okay, so for example, the type of activities and possible question for you to ask during the EDA might be, hello, yes, can, sorry, can you mute your microphone? Who's speaking there? Is it Li Liao? Can you mute? All right. Please mute your mic. All right. Where am I? Okay, it's okay, Li Liao. It's okay. Okay, so the type of activity and possible question to ask during the EDA might be you need to count the number of record in your data sets. Okay, so is this, you can ask the question like, is this what you expected? Is this the size of record that you expected? Right? So you can also ask what are the data types, right? Will you need to change or clean the data set, the data set before you pump in, for example, to your machine learning model, right? So in EDA also is in this stage also, where we look for a missing value. Okay, we look for a missing value in your data set during the EDA stage. Okay, and then you need to think how you're going to deal with this, how you're going to deal with the issue of the missing value. We need to solve this problem before we use the data set. Right, so and then maybe you could verify the distribution of each column. Right, are they matching the distribution that you expected? Is it normally distributed? Right, so in this stage also, in the EDA also, you can search if there is some outliers, are there anomalies in your data? Does all the value is valid? All right, for example, if you want to use a data set of human that include the age, all right, so maybe you could look into whether is it relevant or not, the value is the value is less than 0. So what happened is the value is less than 0 for the column age. It's not a valid data set, right? It's not a valid data set, right? So you need to validate it if your data is balanced. A different group represented in your data. Are there enough example of each class that you wish to predict? And the last one, maybe you can ask, is there bias in your data? So when you have look, when you get your data, you want to see whether there is a bias in your data. Are the subgroups in your data treated more favorable than others, right? So this kind of question that is a lot more. Actually, it's a lot more question. It's just an example, part of it. The example of questions that you could ask during the EDA process or during the exploratory of the data sets. Okay. So why is it so important? Yeah. Okay, why is that it's very important, yeah, this EDA stage. Okay, because yeah, EDA helps researchers, yeah, to maximize the understanding of the data sets, right? To uncover underlying structure of the data. EDA also, yeah, can help you to extract important variables, to detect some outliers or any possible anomalies, to test underlying assumptions, and to investigate interactions among the factors. Okay. So why is it it's very critical to get to know the data before you start on any exercise or any experiment or any modeling, right? So you need, yeah, to explore the data, to understand your data thoroughly, right? Okay, you need to know, yeah, the characteristic of the data. Actually, there is some discussion is happening in the chat box. Let me stop first the lecture. What is the issues there? Some of you didn't get the lecture video and also the lecture notes. I think that is from the EKC 500 students. Am I right? Am I right? Yeah. Okay. You don't have the access, yeah, to the e-learning to the CCS591 because I upload all of the lecture notes and also video there. But unfortunately, you didn't get the access to the e-learning. So what I'm going to do, yeah, I'm going to email to you the documents, right? I'm going to email to you the documents to all the EKC 500 students. Is it okay? Okay, if you thank you, Yan Bing Zan. He did share the link, but I don't think you can access the link because you don't have, the access. You only have the access for the EKC 500. Maybe you could try and let me know what's the outcome, right? But if you still can't access, I will email to you the slides.
Hello,
And
doctor. Hello,
yeah,
doctor.
yeah.
It's accessible. It's accessible. I'm not EK student, but it's accessible. I've already downloaded it.
So you share with them?
It's already downloaded. The link is accessible. No
Uh,
need for password or anything.
Raji, are you from the mixed mode student or the EKC 500 student?
No, I'm not from EK student, but I've already tried the link. It's working. They can download, the EK student can download it.
I don't think the EKC student can download that because they can't. Yeah, correct, Zubao. They don't have the access. Unfortunately, they don't have the access to the e-learning of the CCS591. They only have access for the EKC 500. So what I'm going to do is that after this class, I'm going to share with them and email to them all of the document. All right? So don't worry too much, yeah? Don't worry too much about this. Okay, everyone, can I continue to the class? Hello? Who's speaking there?
Sorry,
Yes,
Doctor.
my name is
Can
Mus'ab.
we the record?
From the group EK500.
Mm-hmm.
I've accessed the link and I put my username and password. Then it's direct me
Okay.
to the my e-learning page. I see CC591 research. I see your name, Dr. Fadlallah.
Mm-mm.
Sorry, Dr. Fadila. And I see I can click on your name, but there's also guest access. What should I do? There is password or just click submit. Just I to do submit or what you do anything.
Musa, I'm a bit confused now. Are you going to download the slide or are you going to submit the assignment?
No, I click the link that you put it in the chat. That click on yes for everyone. Click
Musa, you are from the EKC 500?
yes.
Okay, for the EKC 500, you don't have the access for the e-learning. So what I'm going to do after this class, I'm going to email to you all documents. You cannot access that. You cannot access any document from the e-learning under my name. Okay? So can we stop this discussion so that I can continue with the class? Is it okay, Musa?
Thank you. I'm sorry.
Oh,
I
no
think
worries.
I thought that I can. Thank you.
No, you can't. Okay, let me. All right. Don't worry about that too much. For the EKC, there will be another group of that. Okay, I will email to all of you after this. Okay, so where am I now? The data characteristic. All right. So when you have the data set, okay, when you have the access to the data set, you need to know, the data characteristic, right? Whether it continues type of the data or discrete data set, whether it binary or numeric, whether it an ordered data such as temporal, sequence, and so on, or whether it is a special data set that have some attributes like position, space, and so on, right? So you need to know your data set. Once you get the data, you need to know, you need to read what is the column is all about and what and each value in the column what is stand for. Okay, so you need to know before you pump in your data in your model, right? So I'm going to give to you another set of data set. Okay, so this is from a real experiment. I took this sample of data from my experiment. Okay, my simulation experiment that I use some evolutionary algorithm, which is GA. So for the number column, the first row, the number 1, 2 until number 10, is the simulation number. So I run like 10 simulation. Okay, so for each simulation, the looping or the iteration is 500. So I will have like 500s of the rows, right? Okay, so if you have a look in detail of the data set, it has lots of number, 1.998 until 7, right? So, and if you look into this data set, you will see 2 rows, which is in the red colors and also the green colors. So what I did with the data set, once it generated from my empirical simulation, I will look into the column with the small smallest value, and also the column that will generate the average value of the highest value. All right, so it shows that in my experiment, yeah, the loop number 5 is the lowest fitness value that I have collected, and also the green column, which is the numbers, the 7th column, yeah, is the most is the loop with the highest fitness value, right? So the value here in this data set, they represent the fitness value of the algorithm that I have run in my experiment, right? Okay. So here are the 4 generic steps when we do the EDA. Okay, here are the 4 steps, yeah, in EDA. The first thing is you need to understand your data. Okay, how you going to do that? How are you going to do that? You need to check, yeah, when you get your data set, you need to check your first 5 rows, right? And then also check the value inside your last 5 rows. Okay, and then check, yeah, the total number of rows and also the columns. All right, and then you need to summarize your data into a descriptive statistics. So what is the descriptive statistics? What are the value that show in the descriptive statistic? They are the mean or average value, the standard deviation value, the minimum, the maximum value, the Q1, Q2, Q3, and also the column name. Q1 is the 25% of the data, Q2 is the 50% of the data, Q3 is the 75% of the data, right? So this is how we do, yeah, the first step, yeah, in understanding the data, right? You need to first check your first 5 row of the data, check your last 5 row of the data, check the total number of row and column, and then summarize your data set into a descriptive statistic, right? So that is the first step. Okay, and the second step is you need to clean your data. If your data set has any noise, bias, bad outliers, or drop unnecessary column data that you think is not related to your research experiment. Okay, so in the second step, do the relationship analysis. Do the relationships analysis. Okay, so such as correlation among the selected variable. In this stage, we want to see how the dependent variable, how strong the dependent variable depends to the independent variable, right? So the last step is to plot your data. All right, plot the analysis of the data using the scatter plot, the box plot, or any other plot, the line graph, right, or even a pie chart that is suitable to your result. Okay. Okay, there are a few types of EDA. There are univariate analysis, bivariate analysis, and multivariate analysis, right? So univariate analysis, is the analysis of one variable that you want to analyze at a time. Okay, bivariate analysis is 2 variables that are analyzed together and examined for any possible association between those 2 variables, right? Multivariate analysis is the concern is to analyze more than 2 variables at one time, right? Okay, so it depends, the selection of data analysis, whether univariate, or you want to use bivariate, or you want to use multivariate. It depends, yeah, on the number of variables, type of data, and focus of the statistical inquiry. Okay. Okay. So for the univariate analysis, yeah, is the most basic form of statistical data analysis technique, right? So when the data contains only one variable and doesn't deal with a cause or effect relationship, then a univariate analysis technique is used, right? So for instance, yeah, in the example that I show you in the slide, okay, in a survey of a classroom, the researcher may be looking to count, yeah, the number of students, boys and girls. So in this example, so the data would simply just reflect um, the number, for example, a single variable and its quantity as shows in the table, right? So the main objective here of univariate analysis is to describe the data to find the pattern within the data set, right? So this is done by looking into the descriptive statistic, which is look into their mean value, median mode, dispersion, variance range, and also the standard deviation value. Take note, yeah. Take note, yeah. It's a good practice, yeah, as a scientist, for us to perform univariate analysis on each of the components of a multivariate analysis before we perform the multivariate EDA, right? Okay, how univariate analysis is conducted? Okay, so univariate analysis here is conducted through several ways, which are mostly descriptive in nature. Okay, we can use the frequency distribution table, histogram, frequency polygons, pie chart, and also the bar charts. Okay, so the usual goal of univariate EDA is to better appreciate the sample distribution and also to make some tentative conclusion about what population distribution are compatible with the sample distribution. In this stage also, yeah, sometimes outlier detection is also a part of this univariate analysis. Now, bivariate analysis, right? So bivariate analysis here is slightly more analytical than univariate analysis, right? So when the data set contains two variables and researchers aim, yeah, to undertake comparison between the two data set, then bivariate analysis is the right type of analysis technique. Okay, so for example, as shows in the slide here, in a survey of a classroom, the researcher may be looking to analyze the ratio of students who score above 85%, corresponding to their genders. So in this case here, there are two variables. First one, gender, okay, X is an independent variable, and also the result, which is Y, the dependent variable. So a bivariate analysis will measure the correlation between the two variables as shown in the table below, right? Okay, so how is the bivariate analysis is done, is conducted, right? We can do the correlation coefficients. Okay, the first one. So yeah, correlation is a statistical association technique where strengths of relationship between two variables are observed. It shows the strength as strong or weak correlation and are rated on a scale of -1 to 1, where value 1 is a perfect direct correlation, while -1 is a perfect inverse correlation, and 0 meaning there is no correlation. All right. So the second one is the regression analysis. Right. Regression analysis is used for estimating the relationship between two different variables. Okay, it includes techniques for modeling and analyzing several variables when the focus is on the relationship between a dependent variable and one or more independent variables, right? So it helps to understand how the value of the dependent variable changes when any of the independent variable is changed. So regression analysis is used for advanced data modeling purposes, like if you want to do prediction or forecasting, right? So there are a range of different techniques used depending on the nature of variable and the type of analysis sought by the research, right? So for example, you can do linear regression, simple regression, polynomial regression, and so on. Okay. Okay, here is the difference between the correlation and also the regression. Okay, so there are some key differences between these two, correlation and also regression, that is quite important in understanding these two differences. So the first one, regression will establish how X will causes Y to change, how the independent variable will causes its dependent variable to change, and the result will change if X and Y are swapped, right? With correlation, X and Y are variables that can be interchanged and get the same result, right? So correlation is a single stats or data point, whereas regression is the entire equation with all the data points that are represented with a line, right? The correlation shows the relationship between the two variables, while regression allows us to see how one affects the other. Okay, so the data shown with regressions establish a cause and effect. When one changes, so does the other, and not always in the same direction. While in correlation, the variable move together. Okay, so for the multivariate analysis, it's more complex. It's more complex. Okay. From a statistical analysis techniques, and it's used when there are more than two variables in the data set. Okay. So for example, let's see, a medical doctor has collected data on cholesterol, blood pressure, and also weight of the patients. Okay, the doctor also collected the data on the eating habits of the patient. Okay, for example, how many ounce of red meat, fish, dairy product, and chocolate the patient consume per week. Okay, so the doctor wants to investigate. He or she wants to investigate the relationship between the three measures of health and eating habits. So in this case, a multivariate analysis would be required to understand the relationship of each variable with each other. Right? So commonly used multivariate analysis technique include the factor analysis, cluster analysis, variance analysis, discriminant multidimensional PCA, and also the redundancy analysis. Okay. So this is the like a flow chart when we can use all the type of the multi-analysis technique, multivariate analysis technique in the research methodology, right? So multivariate analysis technique which can be conveniently we can classify into broad category of the visualization, whether it's dependent methods and interdependence method, right? This sort of classification depends upon your question. Some of the involved variable dependent upon other. If the answer is yes, we have dependence method. But in case the answer is no, we have interdependence methods, right? Two more questions are relevant for understanding the nature of multivariate techniques, right? Firstly, in case some variables are dependent. So the question is how many variables are dependent, right? So the other question is whether the data are metric or non-metric. So this means whether the data are quantitative, collected on interval or ratio scale, or whether the data are qualitative, collected on nominal or ordinal scale, right? So the techniques to be used for a given situation depends upon the answer to all these very questions, right? So this diagram, this flowchart diagram, is I took from the article called "The Multivariate Revolution in Marketing Research," and the author name is Jadish and Chase, right? So he has given a very clear flow chart that clearly exhibit the nature of some important multivariate techniques as shows in the slide. Okay, so we have two types of multivariate techniques. One type for data that contain both dependent and also independent, and the other type of data that contain several variables without dependency relationship, right? So in the former category are include techniques like multiple regression analysis, multiple discriminant analysis, multivariate analysis or variant, and canonical analysis. Whereas in the latter category, we put techniques like factor analysis, cluster analysis, multidimensional scaling or MDS, right? Okay, here we go to the second section of today's topic, sampling. Okay. Okay, to understand the underlying process here, we need to collect some data. Okay, to collect data and to form an idea of what could be the factors and how they interrelate with each other. Okay, this here could be done through sampling. Okay. So in a real life, it's very impossible and it's very time consuming or very expensive to collect a large amount of data in many cases, right? For example, if you want to study the effects of the new medical drugs to patient across Malaysia, or it would be impossible for us to collect all the data, yeah, for every population for the whole Malaysia. Okay, so that is where we need the sampling. We only take a certain percentage of the sample from the real population. All right, because sampling is like a representative data from the population is often required in empirical study, right? So statistical inference from that sample data can provide some knowledge about that larger population. Okay, it will infer the result from that population only by using the one sample from that population. Yeah, sampling from a real population. Yeah, so suppose that you want to collect a data from population, as there could be millions of samples available for you to choose from. So the best approach to represent the sample is to do the random sampling, right? There is a lot of sampling technique, but normally the best is you need to collect the random sample. Surprisingly, the best way to sample is to collect a random sample as opposed to non-random sampling, such as quota samples or judgment samples. Okay, this is a simple technique of the first random sampling. It's called simple random sampling without replacement. Okay, simple random sampling without replacement, right? So the list of population, for example, as shown in the slide, is given from number 1 to n. Okay, so a sequence of n random numbers are taken out or drawn from the numbers 1 to n, right? So each time a number is taken out, it is removed from the list so that it cannot be considered again. So therefore, each item has an equal chance of being selected as a sample, right? So most sample proportion would be close to proportion in the population, but may not to be exact. Okay, another random sampling technique is a stratified random sampling. Stratified random sampling. Okay, so population could be divided in this stratified random sampling. Population will be divided into subpopulation that we call strata. Right. So a simple random sample would be then chosen from each of the stratum. A sample size is proportional to the stratum size, right? So every item has an equal chance of being selected. So this sampling method will result in sample that more accurately reflects the proportion in the population as compared to the previous one, which is the simple random sampling. Another sample is that the systematic sampling, right? We will select every item on the list, right? Okay, maybe third item on the list. Every time we select, we will select a third item of the list, for example. So randomness can be introduced by randomly picking the first element. So therefore, first unit is random and following units are sampled at fixed interval. Typically, used when population size is too large and list of population is available. Another example is a cluster random sampling. Cluster random sampling is used when the population is scattered across a wide area or if the evident groupings are known to exist in population. Okay, could be area-based, area is divided into neighborhood called cluster. Okay, in stratified sampling, yeah, a random sample is taken out, yeah, from each of the strata or stratum. Whereas in the cluster sampling, only the selected cluster are studied, right? So the main objective of cluster sampling is to reduce the cost by increasing sampling efficiency. Okay, another examples is the lazy one, right? It's called the convenient sampling, right? Convenient sampling. It is used when it is difficult or very expensive to collect sufficient sample for an experiment. So a selection of sample is determined by ease of sample collection. It may not represent a population, and also it somehow can generate some bias, right? Okay, another subtopic for today, the third subtopic is the how you're going to display and summarizing your data. Okay, I'm going to show you some example of non-significant table of result. Okay, this is very important, yeah, for you as a researcher. When you do the reporting, yeah, once you finish your experiment and you have collected your result, okay, this is another important part is how you're going to summarize your data and how you going what type of data that you need to share with public, or in your case maybe you want to share in your report so that the examiners and also the supervisor can read, right? My advice is that do not put all of your result. Okay, do not dump all of your result. Okay, the student normally, especially my student, they tend to put all of the result. Okay, because they think all is very important. No, not all results are important. Okay, you need to go back to your objective. What is your main objective? Okay, then you will understand only some significant value you need to put in your report, not all the report, not all in your report. For example, this is a very bad example. It's a mixed mode student works that last few years. Okay, I examine the student. Okay, so the student research is about, if I'm not mistaken, is about the performance evaluation of every machine in the factory. Okay, so apart from a method, is to collect the interview data to get some opinion from the staff, from every department, right? So she report and discuss the unnecessary data from her interview. Like, she shows the result of part 1 interview. Okay, so this is not an important data. Why she need to show all of the position and also the department staff with their years of services? That is not important result, right? That is not important result. So do avoid to put insignificant result in your report. It will end up your examiner will get bored. Okay, because normally the examiner only look into the significant result, the one that could answer your problem statement, the one that could support your research objective. Okay, so this kind of information is not important to put in your report. All right. Okay, here's how we display and summarizing your data. Okay, so it's very difficult to gain an understanding of the data just by look at the numbers in that table. Okay, so we need to present the data visually as a picture worth 1,000 words. But we must present the correct picture, or else we'll mislead ourselves and also others. Okay. So in the example in the slide, the data in the table, the numerical data in the table has been converted into the line graph. So it's more readable, right? All right. So here are some example of the tools there that we could use when we want to generate, visualize the data in a graphical format. Okay, you can use SPSS, SAS, the R, Weka, Excel, MATLAB, or even Python, right? This is very basic one, huh? A dot chart or dot plot. There is a statistical chart consisting of data points plotted on a simple scale, typically using fill in a circle, also known as a Wilkinson dot plot. It's used to display a single variable. This is the most popular one, yeah. The next chart is the most popular one used in the scientific research, the box plot. Okay, or known as also the whisker diagram. It will display the distribution of data based on the 5-number summary. There are minimum number, the first quartile, the median, the third quartile, a maximum value, right? Okay, so if you can see here, the range from the first quartile to the third quartile is called the IQR, right? This is a very important value. Okay. So box plot, it's very useful when we want to identify any outliers and for comparing the distribution. Okay. Outliers are expected normally distributed data set within more than 10K of the data points. Okay. This is the simplest possible box plot display the full range of variation from minimum to maximum, the likely range of variation, the IQR value, and the typical value, which is the median. Is not uncommonly real data set will display surprisingly high maximum or surprisingly low minimum called the outliers, right? So John Turkey, father of statistics, has provided us a precise definition for two types of outliers. Okay, outliers are either 3 times IQR or more above the third quartile, or the 3 times of IQR or more below the first quartile. Okay, so the suspected outlier, let me show you back the graph. Okay, so the suspected outlier, a slightly more central version of outlier, either 1.5 times IQR or more above the third quartile, or 1.5 times IQR or more below the first quartile, right? So if either type of outlier is present, the whisker or on the appropriate side is taken to 1.5 times IQR from the quartile, the inner fence, right? Rather than the maximum or minimum value, right? So an individual outlying data points are displayed as unfilled circle for suspected outliers. Okay, the one with the white dots, all right, or the filled circle for outliers. Okay. So if you can see, can you see my mouse? Okay, this one is the suspected outlier, the white dots, while the black dots, these two black dots is the real outliers. Okay. Now we want to see the differences between the histogram and also the bar chart. what are the differences between these two? Okay, so the most basic graph is the histogram, which is a bar plot, right? In which each bar represents the frequency or count or proportion, count total number of cases for a range of a value. Typically, the bar runs vertically with the count axis running vertically. To manually construct a histogram, you need to define the range for data for each bar, what we call it bin size, count many cases fall in each bin and draw the bar high enough to indicate the count. Okay. So the frequency table is a tabular representation of the frequency of distribution of the data, can be graphically represented using the histogram. Okay. So this is what the bin size, the effect of bin's width on histogram shape. Okay, you can see clearly, you can see clearly the choice of bin size will affect the shape of the resulting histogram. The optimal bin size can be determined using the Friedman diagonist rule. Alright. So W equal to 2 IQRN power by minus 1 over 3, where IQR is the interquarter range of the data and N is the number of observation in the sample. Okay, some good practices, right? So it is very instructive to look at the multiple sample from the same population, right? To get a feel for the variation that will be found in the histogram. With practice, histogram are one of the best way to quickly learn a lot about your data, including the center tendency value, the spreadness, the modality, shapes, and also the outliers. So to summarize, in a nutshell, you should always perform appropriate EDA before further analysis of your data. Okay, you need to perform whatever step that is necessary to become more familiar with your data, right? So meaning that you need to understand first your data set. How big is your data? What are the features in your data? What is the column name of your data? What is the value of the data? What is the meaning value of each of the data inside the column? Okay, how many rows? Okay, what is the first 5 row? What is the what is you need to check for obvious mistake. You need to learn about variable distribution and you need to learn about relationship between the variable. Okay, the most important things when you get your data, when you have collected your data, you need to understand your data, okay? So that you know which model later on you can use or which algorithm you can use based on the data set. Also, you need to clean. You need to have a clean data set before you pump into your model, all right? Okay, so I think this is the last slide for today class. So for this week I'm going also to release last assignment, which is B2 assignment, right? So this is only for the mixed mode student, okay? Only for the mixed mode student, okay? Same as the B1, right? You need to fill in the name, your metric numbers, dissertation title, and so your supervisor's name. Okay, this is the first section. Okay, and the second section is you need to discuss 3 existing methods or approaches or techniques that related to your proposed research domain, focusing on their limitation and also the gaps, right? So you need to discuss each method in a different paragraph, right? So you need the third section is you need to formulate your hypothesis or suggested a solution to improve the existing related method that you have discussed in the section number 2. You need to briefly explain your your formulated hypothesis or suggested solution in a graph. Okay, part 1 to part 3 must not exceed 1 page A4 size. Right? So the due date is on 21st January 2022. Right? Any questions? Any questions?
Hello, Tito.
Yes, Raji.
I posted 2 questions on the chat box. Before
Oh,
then,
mm.
before then, I think it is assumed that we are going to use qualitative data, because I don't know whether qualitative, I don't know whether qualitative data lend itself to hypothesis testing, because you said we should develop hypothesis testing. Suppose we are using our research involve qualitative data. Are we going to also develop hypothesis testing for that question?
Yeah, no matter what kind of data type, you still need a hypothesis, even you use the qualitative data sets or quantitative data set. You need to have the hypothesis. Okay, Raji?
So if we use qualitative, okay, it's okay.
Yeah. Yeah. So let me read first your in the chat box. Okay, I have read your questions, yeah. It's about the sampling, right?
لرئيس الوزراء مع منح باقي القوى فرصة
You,
اختيار أحد
can someone
هؤلاء
turn on
المرشحين.
Ahmad Abdul, can someone
الرقيق الإخبارية
please mute microphone, yeah, Ahmad. Ahmad, can you turn off your microphone? Okay, let me stop first the sharing. Okay, your question, Raji, is about the sampling method. Yeah, which sampling method is suitable? Am I right? If my understanding correct? Normally, the best sampling method is the random sampling method. Okay, so because it's easy to get the data set, just in this case, from the student that get the lunch. Okay, I don't think if you have how big is the population? How big
Hello,
is the
ma. What? Excuse me, ma. What type of random sampling? Is this stratified random sampling? Is it simple random sampling? Is it cluster sampling?
Does this sample being divided into a cluster or not? Raji,
I don't.
is
Yes, ma.
has been divided into a cluster or strata?
No, I don't know. I just want to do these things. I have not divided it.
So if you are not divided it, all right? So by the way, I wanted to ask you how big is the population?
Is it for the question 1 or question 2? I have two questions. The one involve students reading the library. The second one involve choosing the most popular biro. For the first one,
the library.
yes, the library.
Yeah, how big is the
School of
data
Computer
set?
Science. You know, for the School of Computer Science, we have three sub in the computer science. I mean, we have different units on the for the program.
Oh,
We
so
have informatics,
is
computer
this,
science.
yeah, I wanted to know how big is the data set? How big is the population? How big?
The population. If we look at the number of students we have now, maybe let's assume is 40 for the
Oh,
three units.
if there is less than 40, you don't need to do the sampling. You can just use all the 40 students.
But suppose it's about 200. What happened?
Ah,
200 or 1,000 for the three units: the computer science, data informatics, and the other one. The
so
students all together.
so how many in
They,
your
they are one. They are 1,005.
okay 1,500? Let's say you want to do a sampling, okay? So
Uh,
you don't will you like cluster them or group them, or you just randomly take the student from that sample? You didn't group them? Did you?
no, they are just like that. They are in three different categories that make up the computer science, School of Computer Science. They are like that. And I want to use a
So in
sampling techniques.
so in each category, what are the category?
No, no, we have three subunits. Those who are studying computer science, those who are studying data informatics, and then the other area of specialization.
Okay,
As
so now you have three groups. Let's
uh,
say you have a three group. So you want to take the sample for every groups or not?
and I still have those people, the master by research, master by mixed mode, the PhD. I still have them like that under each of them.
So you want to take the sample from each of the group or not?
Yes, I want to take it so that the sample will represent the entire population, the entire School of Computer Science.
Okay, so if you want to take the sample from every group, yeah, from every group, then it will fall under the stratified random sampling.
Okay, stratified random sampling.
Yeah. So the second question is about what? Let me read back.
What type of sampling technique can we employ to determine the most popular type of biro among all the students at the School of Computer Science using the CSC, attending the CSC591 class?
What is biro?
Biro, the one we used to write, they were using to write now. Using to write down notes, taking down notes. There are different type of biro.
What is, can
The
you
one I'm using now is called big biro. The one I'm using is called big biro. We still have different type.
type what is the type of the biro? Can you type in the chat box?
We have many.
Okay, Abu Bakar. Yes. You can go now, Abu Bakar. Oh yeah, I have an announcement, yeah, before we end the class. So next week class, yeah, there will be asynchronous. I will make an asynchronous mode class, yeah, where I will put my recorded video and upload the slide. There will be no live session next week. Okay, guys, I will upload my recorded lectures. There will, because I want to make an asynchronous mode of the lecture. All right. Okay, bye-bye.
Sorry, doctor, can you hear me?
Yes.
I'm Calvin. Just now we saw a test on the e-learn for the mixed students. So may I know we need to do that for testing purpose only, right?
Yeah. Thank you, On. That is one of the practice that you need to do. So can you guys, all the mixed mode student, yeah, go to the e-learning and try to do the mock-up test because I want you guys to get familiar with the e-learning features before we do the real test.
Real
Can you do it now go to the e-learning? And there is some dummy question to ask. I put some dummy question. You just answer it lah. I don't mark that. Okay, I just want you to get familiar with e-learning. So all of the mixed mode student, can you go to the e-learning now and try the mock-up test and let me know if you have any difficulty. Okay, please do it now. Zhang Han, homework only for the mixed mode student. Let me know, yeah, if you have any difficulty. I will stop for a while, yeah, to pray.
Kí ló dé? Lọ gbé fún kó yọ mí lẹ́nu. O má disturb mi bí báyìí.
Any issues? Is the homework for EKC 500 student? No. Shri, yeah, Shri. I supposed to discuss with you about the research topic. Yes, Shri. I'm available now. Sure, we can discuss it now. So before that, have you, Shri, are you there?
Yes, madam.
Yes, Shri. Have you tried the mock-up test? Is there
I'm
any?
actually trying it, but I thought after the message, right, then attempt.
Okay. So, Shri, you haven't found any supervisor yet?
No, I actually,
Oh,
I
have you?
mean, no,
Dr.
not. Yeah, but the thing is that the topic actually she haven't really finalized the topic for me. Just that her existing student worked on something, so
Oh.
probably she said maybe she would find something for me to further enhance on it. But when
Mm.
I saw your topic, I was a bit interested. It looked a bit interesting, so I thought maybe I could discuss with you further about that, so that maybe we can align it up. And
Yeah,
wanted
okay.
to ask your opinion.
The topic is about what the prediction of the hospital bed capacity. Am I right?
Yes, madam.
Okay, so the thing is, I don't have the data set. The student needs to find the data set.
Okay, so in this case, it's about like me approaching hospitals to get this sort of data. Am I right?
Yeah.
Okay, I think that shouldn't be a problem.
I think that would be an issue of a ethical data set. You know, the hospital they are very, not really sharing the data set to the public. But I don't know if you can get, that would be a bonus lah. Okay,
Okay,
but yeah, you try if you have a difficulty to get from any other hospital in Malaysia, what I would suggest is that you just get the public data set
Mhm.
from the Kaggle or the GitHub. You know Kaggle and GitHub?
I mean, I've heard about it, so probably never get a chance to work on it. But yeah, I
I
would
just
take this
I
as
just type there. So maybe you could like go through the Kaggle and GitHub and go and download any related data set to your research domain. Because once you have the Kaggle and once you have, because the Kaggle and GitHub data set is a free data set. It's a public data set. Everyone can use it. Okay. So, but if the case that you still cannot get the data set, you have to try to Google around or whatever you need to get the data lah.
okay, ma'am. So in this case, it's just that getting the data is the looks like is the first challenge, right?
Yeah, this is the first.
Okay, I'll figure this out. So in that case, is it okay if I finalize this topic, ma'am?
Sure.
Okay, perfect. Because my previous assignments for research empirical, which is the SLR and even the assignment, I think 7.1b is it. So these two, I did it based on cyberbullying.
Oh,
Okay, so that shouldn't be a problem, right, ma'am?
yeah.
Okay, perfect. So then I can start my research on this topic then. Thanks a lot, madam.
No worries. Okay, so
Hello,
okay now.
hel- hello, hello, doctor.
Yeah, Raji.
I've gone through the question. It's as simple as ABC,
Yeah,
but
it's the same.
I don't know what
It's only a
it's
more.
as simple as it's as simple as ABC. I don't know whether this type of question is what we expect, but even then, the question I asked has something to do with what we have just learned, and I would just want to get it right.
Raji, do you
Yes,
understand
ma.
the word mock-up test? Do you understand?
Yes, ma.
Yeah. So that is why the question is easy. I won't
Okay, ma.
I won't grade you for that mock-up test. That is for you to familiarize with the e-learning features. All right. So for the real test, you will get ready with all the features. The main aim of the mock-up test is to get you familiarized with all the features in the e-learning. Okay, Raji?
Yes, ma.
All right.
But
Next question.
concerning my question, you have not answered the second one. I just want to understand all the things we have taught regarding this sampling technique.
Mm-hmm. So what type of sampling technique can we employ to determine the most popular type of biro among all the students at the School of Computer Science using the CCS591? Still the random sampling. Okay,
What type
next,
of random sampling?
yeah. Next question from Musa. Yes, Musa.
Assalamu alaikum.
Waalaikumsalam.
Doctor, about Fidel, I got a data set that's very fine. But also I got a
Can you
data from
introduce
GitHub.
first? Musa,
Yeah.
can you introduce first? Because I have like 3 types of student in this class. So may I know, are you a research student or you are from
Yes.
the EKC
Yes.
or you are from the mixed mode? You
Research.
are
PhD
from
research.
EKC.
Yes.
Okay, Musa. You're
Yeah.
from EKC.
Doctor, about Kaggle, I found a good data set.
Mm-hmm.
Also, I found a data set very huge in GitHub, but it is in the format .mat. I wanted to open it to see if it's relevant or not. I couldn't open it.
Is it
Is
corrupted?
your advice for me?
Is it the data corrupted?
Not.
Is it in the .csv file?
No. The mat file, MATLAB.
It's a MATLAB file. Have you tried? Oh, that is the file is the MATLAB extension.
Yes, MAT.
Oh, then why you cannot open it? You are using the MATLAB, right? You're
No.
using the MATLAB.
No,
Oh.
but the data title very interesting. So I want to see what is this data set. Maybe it's relevant or not.
can you export the data set to the .csv so that you can open it whether
5 giga.
oh
But I can use, if you want, if I mean, I can make it in my Google document and give you a share or like that.
no need you oh I think it's can you open it using a MATLAB? You
I
open it.
didn't use it. For that, in our university, it is licensed one. There is two types of
correct.
lab.
It's license.
One of them there is online, and the other can I download at my computer. So in our university, do we have an access to download? Because they asked me a license.
I think we have a license in our lab, but I don't know for how many people because I think it's a limited one. So maybe you could who is your
don't know this license. I don't know what the number of the license. This is the first
who is your supervisor?
Dr. Chu.
Dr. Shu. Maybe you could ask her if she has the license for the MATLAB.
That's good that you told me that the university have a license. Then can I ask my supervisor?
You ask the supervisor. I think we have the license, but I don't know for how many because it's very limited. Because in your case, yeah, if you have a MATLAB data set, you have in what application you open it in which using what? Using Python, R or what?
Python, yes.
You're using what? Python, R?
Python, doctor.
You're using a Python. You try to open the MATLAB. Try to open the MATLAB. Go and ask Dr. Chu, yeah, for the license.
Thank you, doctor.
Okay, welcome. Who else? Any questions? No more question? So, password. What is the review result? Kaijing by. What is the review result? I don't understand.
I mean the result of the mock-up test.
Oh, mock-up test. I don't grade, yeah, the mock-up test. It just wants to help you to get familiar with the features in the e-learning. So I don't grade that. All right. So doctor, what are the topic for the test one? All the topic from me. All the topic from me. From my side. From my section B. I just want to see how the result looks like. No, I don't grade. Okay, everyone. Thank you so much. If there is no more questions, I will end the session. All right. Thank you. Have a nice day. Bye-bye.
Thank you.
Bye.
Bye bye.